Now, naturally, when we're working with arrays, the arrays are working with scenes are one-dimension arrays. In memory, physically, the physical look of a memory is a straight tape of byte. A straight tape of byte, just one single straight tape of byte. Because the reason why we say it's a straight tape of byte is because the first every cell in the array is what is a byte. Every cell in the array is a byte. So when we say memory is the physical memory is a straight tape of byte, it means it goes on like this, it goes on a straight line like this. But if we want to think about them logically, then we'll start to do these diagrams. So we want to think about the arrays logically, then we start to do diagrams like this. So we'll talk about two-dimension arrays. We are talking about arrays that are represented by um by two subscripts like a row and a column. So let me declare a two-dimension array for you so that you get what I'm trying to say. Say int, for example, int a say 2, 3. Now what we just did now is to declare a two-dimension array. If you want to think about a two-dimension array using the same logical sense that we use for the one-dimension array, we could say, okay, this is a row. This first braces here represent the row. While the second braces here represents the column. So logically, if you want to think about it, we could say, okay, two rows, three columns. So we could demarcate it like this. Two rows, three columns. This is row 1, index number 0, index number 1. Here, column 1, index number 0, index number 1, index number 2. You get?
Yes.
So that is how it works. Now, in this particular situation, if we want to initialize something like this now, we could say, okay, equal to 1, 2, 3, 4, 5, and 6. So that while we were in the elements will go like this: 1, 2, 3, 4, 5, and 6. Do you understand? Or
Yes.
we could use another method to initialize it. Since we could use another method to initialize it. But I would not really want to use that method because it's still the same thing. Why people do that? So let's just continue anyways. So that's how you work with a two-dimension arrays. In two dimension arrays, we have a row and column elements. Row and column elements. The reason this is not how it looks in memory, this is how the memory looks like, but for the sake of reasoning, we have to reason it this way to help us understand how to work with it. The next thing we'll do is we'll learn how to um what insert elements or initialize a two-dimension array using what a printf for using a for loop. In 1D array, we take in one value, or rather we use a for loop. We use just one for loop to take in a value. But in 2D array, we use two for loops. Two for loops will be required when initializing it at runtime. So before we do that, let us discuss how address is being administered here. Now, suppose the base address for this particular array A is 100, right? If the base address is 100, the first element here will amount to what? 100.
100.
Now, because each element of this particular array is of type int, the second
Int.
element we go what? We amount to what? 1 over 4
104.
because of the size of what? The data type int. Data type int is 4 bytes. So it increments by
4
4.
bytes.
So also it goes on 108,
8,
112,
12, 16,
116,
120.
120. So now you understand how it works. Now we can access the elements of this particular two-dimension array by using what? By using um by using the index number. Please take notes. By using the index number, we can access the elements in what? In a two-dimension array. How do we do that? Now, if you see here, the index number for the column starts from 0 as it should, 0, 1, 2, right? And the index number for the row start from 0, 1, 2. If we look at the way it is arranged when we're declaring it, the row came first before the column. So usually in a one-dimension array, a situation like this, right? Let me say here contains 7 and the index number of the cell where 7 is contained is what? 3.
3.
If I want to access that, all I need to do, maybe if I want to get the address of this particular element using a pointer variable, of course, maybe I can say p is equals to address of what? If the name of the variable is a, for is if okay, the name of the variable is x, right? Of x 3. Are you seeing that?
Yes.
So I'm able to access this particular element of what? The array. This way. I could even do something like this. I could say, okay, printf Maybe I just want to print only that element only. I just want to print that element only. I will go print F, do my double quotes, right? My placeholder, integer. Someone is about to sleep there.
Sorry.
My placeholder integer, then comma, and then I'll go like this. X. Which element am I printing? The element that is in what? Index 3. That would be good. So just print only that element. So how do we locate elements in a two-dimension array? Let me let me make this more
We
neat.
put the
What? Ayola, you say what?
just kind of the same way, sha, but if I were to print a two locate an index of okay, look at an element of two dimensional, sorry, array. So we do, instead of using like print f percentage d x3. So let's say the name of the array is x, like you stated here. So we can just do, and we have column two, row two and column three. So I want to locate the want to pick the element in row one. Okay, let's say row two, column two. We just write x, then we'll open the bracket, we'll put two, and open the other bracket two and write two. So the index, oh, so the index will be one, one, one.
Can you come again, please? Sorry.
Okay, draw the this thing finish first.
Okay. This is 1, 2, 3, 4, 5, then 6. So
Okay,
now,
now
what are you saying?
let's say you want to print, let's say you want to print five, which is row two, row two, column two. But if you are to say it, that's row one. If you are to identify it when printing, we just do, let's say the name of the array is x. So that will be x, then the bracket one, and the other bracket also one, because we'll start from a zero instead of one. So it will be row one, column one. Wait, am I saying? Yeah.
Like this, right?
Yeah, it should be like this.
Okay, you are correct. Because if you look now, the row starts to count from 0, row 0, row 1, column 0, column 1, column 2. So here, the index for this is x 0, 0, x 0, 1, x 0, 2. Right? Here we have x 0, no,
No, that will be 1 0.
1, 0, sorry. x 1, Yeah. Then we have x11 and x11, the x11 and x12. So these are the indexes for each of the elements in this array. This is how we get the indexes. X12. So now with this in mind, now coupled with the understanding that we already have on how to initialize our one dimension array, we can use the same logic to initialize our two-dimension array. But in this case, if we want to initialize our two-dimension array, it will require us to use a two for loop, because one loop is going to represent the row while the second loop is going to represent the column. So that's what we'll do now. So let's go over to our code. Right, so you see the name of the array is A. A is a what? 2 by 3 array. Let's put so now we can use the printf function and the scanf function to get our information, to get the elements into the array. Printf now remember, because we are dealing with two-dimension array, we use what? Two loops.
I.
We use two loops. For I equal to what? 0.
0. I less than 2.
Yeah. For I equals to 0. Check if I is less than 2. Increment I.
I plus plus.
All these people, where are they even
For
coming from?
J.
Yeah, Ayola, where you go and park all this crowd from?
I thought all of them have left.
Some of them are just keep coming.
Eh, maybe it was the one I sent before.
Okay, you were sending the link to them.
Yeah, I sent the link to them actually.
Okay. So for I equals to 0, check if I is less than 2, increment I. So what do we do here now? We will have to create another loop. This one is for the row. Remember, Mr. I and Mr. J, when we're talking about loops,
Yeah,
right? So this one is for
when we're
the,
printing the hash.
yeah. So now this one is, okay, let me, sorry. All these not sleep.
Copy and paste.
When J is equals to 0, right? Check if J is less than 3.
J less than 3.
Increment J. So what do we want to do here? We want to read in the information. Scanf, right?
Percentage D.
So then we'll note notation will be like this. I,
I and J.
yeah, J. So that's basically it. So after it has finished scanning, it goes out of the loop. Now if we want to print what we just did, go back. You can say for, you can say printf the elements of the array are, go back again to print another for, right? Check if I, the same thing, is equals to 0. When check if I equals to 0, check if I is less than 2,
So
increment I. For I is equals
J.
to what? Okay, sorry, for J. J is equals to 0. We check if J is less than 3. Do you say less than 3? Yeah, less than 3.
Yeah, 11.
So it's not be up to 3. So that we say J increment printf
Network.
printf a new line. Come on. New line. So then go out of the loop as usual. Return
Return
0.
0.
Tosin, you raised your hand. What's up?
Yeah, sorry, I wanted to clarify something. I was not, I went offline for some time, so I wanted to confirm something. Now, for the for loops you are using for I, since it's two rows, you use I is less than two for the
Yeah.
first for loop. So I was wondering, um, can you also use, since you are dealing with two rows, ca- can you also use I is less than or equals to uh 0, 1, 2, 2? Okay, that's where I don't understand.
Yeah, we
Since
talk.
yeah, go on, go on.
Okay, the reason why we are doing that is because of this index. This is index numbers, right?
Yes,
So for each
yes,
cell of the array, the counting of the index number start from zero, right?
yes,
So
yeah,
if we say
yeah.
check if I, sorry, check if I is
Mm-hmm.
less than 3, for example. Hmm? We are trying to
Okay,
tell him
yes,
that iterate from 0 to 1, from 1, that is 1, 2, right?
yes, yes,
So it will
yes.
work from here, 1, 2.
Hmm.
Do you understand me? 3. He's not going to get
Okay,
to 3 because he's counting from 0. Remember, 0, 1, 2. But it's not going to get to 3. But if we add equal to here, it's going to check. This particular statement is checking. Is I less than or equals to 3? Yes. So we'll work on 0. It will go to check again. Is I less than or equals to 3? Yes, it work on 1. Is I less than or equals to 3? Yes, it equals to 2. It work on 2. Is I less than 3? No. Is I equals to 3? Yes. So it will work on 3. But if we remove that equal to sign, right? If we
yes.
remove the equal to sign, for example, now, so that it will just be um, the lesser than
Just
sign.
less than.
What this statement means that you're going to check is I less than 3? Yes, to work on 0. Remember, we are incrementing. Oh,
Yes,
this
yes.
I plus plus is changing the value, it's counting. When I
Yeah,
is equals to 0, we check here. Is I less than 3? Yes.
yes, it
Then it
is.
work on 0. Then it will increment this to 1. Is I less than 1? Yes. Is I less than sorry, is I less than 3? Yes, it's here.
Mm,
Is I less than 3? Yes. 2 when it's in 2, because 2 is less than 3. But when he increments to 3 now, is I less than 3?
no,
No, I is not less than 3.
yeah.
So it breaks out. But if I add the equal to
Okay,
sign here,
it will have
is
to
yeah,
work on
it will
three
check
too.
is I less than 3? No. Or is I equals to 3? Yes, I is equals to 3. So it will work with that.
Okay, so now, in other words, for that code that you're writing, for I can also write I is less than or equals to 1 there, and it will work.
Yeah, but it will stop work. The loop will stop running when it gets to 1. And 1 is not the of course you can do that, yeah. You can do that. You can do that, yeah. Yeah, we can do
And
that. We can do in this place here.
oh,
We can do that. Like here now. You can say
okay.
got it. But if you look, this one is what? This one is a column, right? This is the row.
Yes.
Check if
Yes,
I
no.
is less than or equal to what? 1. You see that we can do that too. It will still work. The same thing.
Okay.
Every night, Monday.
Do you understand?
Thank you. Yes, yes, I do. I do
Yeah.
now.
So,
Okay.
all right. So let's run this thing and see how it goes.
tí wàá gbé mọ́ wọn pé jókòó.
Okay, format D expects argument of type int, but argument 2 has type int. Okay, let's see what's going on there. This is another code. Function main, line 14. Line 14. Okay.
I don't see anything wrong with that now.
No, me, I don't see anything wrong here. So what's that the issue? You're talking about the type. There's nothing wrong.
Oh, you did not put the address.
The address. Okay, I'm scanning.
Address. Yeah.
See, just that's the power of debugging. Just one little error now, you are gone. Okay, all right. Okay. Kindly enter your array elements. 45, 54, 77, 23, 44, 12. The elements of the array are 45, 54, 77, 23, 32, 12. These are the elements of the arrays.
I think we should use tab in that place to make the output more okay, more fine.
No, you can just do this. You can just do this.
Okay, space.
Yeah.
Okay.
32, 41. So you can see. You saw how it represent how it became, right? Row and column. So I think with all this information that we have today, okay, I think there's one more thing concerning arrays. We need to know how to work with very important um two very important functions. Two very important functions in arrays that ALX would really ask you guys to work with. So let's treat them now. Okay. So now we'll talk about two very important functions called the mem copy and the mem set. mem copy, don't mind my writing, and the mem set. Mem set is used to fill a block of memory with a particular value. The mem set is used, this function is used to fill a block of memory with a particular value. That's what it does. The other one is called a mem copy. We'll first of all deal with the mem set first. So this is how it works here. This mem set now. Let's say this is the how do I put it? Let me write the prototype of this function. It returns a void value, doesn't return anything. This is a pointer function. I don't know what is pointing there. Sure, let me just use this thing. Hashtag include. So this is what the function does. What you do, I think it works mostly with strings and a little bit of array, but mostly with strings actually. It works mostly with strings, but sometimes array. Not really much with array though. So he's going to set a particular, he's going to fill a particular block of memory with a particular value. You know, if you have been to the bank, right? When you went to go to collect your ATM card, they don't completely print out the numbers. In a particular place, you see SSS and all of that, right? Hello.
Yes, yes, we are here.
Yes,
Yeah,
yes.
yeah.
Yeah. So you can use this particular function to recreate something like that in memory. I mean, in your code. So the memset function takes in three parameters. It takes in three parameters. The first one is the starting address of memory to be filled. The second one is the value to be filled. The third one is what? Is the bytes, the number of bytes to be filled, starting from that particular address to be filled. So I'll just write a very simple program that will demonstrate how it works. So let me say I declare a string. It's usually with strings, usually works with strings. Let me set it to 50, right? And I come here and I said something like this. Dot free is an elite. Hope I've not exceeded 50. 1, 2, 3, 4, 5, 6. No, I'm not exceeded 50. Sorry. Too much of printf. So I've done that now. Now I can say, to show you the effect of what I did, I can do something like this. This is before memset. Right. Tomorrow, what do you guys have tomorrow? Peer learning day.
No, we have our first task on Harry tomorrow. First project on Harry.
Right. Come here, say str. Right. So we have done that now. Now I want to use a memset function. In the memset function, like I said, it takes in 3 parameters. So if you want to write it, might say memset, starting from where you want to put those characters. So string, right, plus maybe I want to start from that's from my base address. Now from my base address, maybe, because you know that this particular um, string is of what type? Character, right? And type char is just 1 byte in memory, so it's more like taking one step. So maybe I want to take like 7 steps from my base address. That's what that place mean. The first is the starting address of memory to be filled. The first place in memory that should be filled by using this one. The second one is the kind of value I want to be filled. Maybe I want X to be the value, the character I want to fill all those things up, right? So I'll put it in single quote because it's a character. And then the size of what? The size of the character, or rather the number of bytes to be filled.
So the data type.
The number of bytes that I want this thing to fill now. So because I'm going to take how many space? I will determine the number of space. Okay, let me say I want X, right? Maybe I want like 7 X's or maybe 6 X's, right? So I can just say 6 times, then I'll bring the size of function as 6 times the size of six times the size of what? Car. 6 times the size of car. Are you seeing this?
Yes.
So the
Yeah.
memset
Yeah.
function takes in three what? Three parameters. Number one, where I'm going to start printing from. Number two, the character I'm going to print in. And this one is what? The number of bytes I will be filling with this character. So because it's of size car, which is 1 byte now, how many of these will I want to print? I say 6. You get? So this is how it works. This is what we'll do now. Come here and say memset str plus 7. Then plot want to use a fill. And how many you want to use? 1, 2, 3, 4, 5, 6, 7. So let's use 7 too. For example, right? Times size of car. Then you can now come here and say f aftermath of memset is what? Same str, okay? Uh, 12 and 11. Okay.
The errors from your return 0.
Yeah, you know, add a new line after this one. So you can see this is before what? Memset. The first one, the string I created, Godfrey is an elite developer. After we use the memset, this is what this string became. Godfrey, elite developer. So he blocked this particular place with this particular what character. Are we together, guys?
Yes,
Yeah,
Yeah,
together.
yes.
So we'll go and do the last one before, I don't know, I think we should call it a day because we've really spent a lot of time. I would have loved to attempt the questions with us, but oh man, I'm beginning to feel it. What I want to say is mem copy, right? Mem copy. Mem copy. Okay, yeah, what does mem copy do again? Alright, the copies, I think, yeah. The mem copy copies characters from a memory area to another memory area. So there's a source memory area and then there's a destination memory area. Both of them are pointers. So it's very easy, very, this one is much more easier. So we create two strings. We create two strings. One is going to be the source string, and the second one is the what destination string. So what we'll do is that we'll copy the what's it called? We'll copy the characters that are in the source string to the destination string. Now, this same function works in nearly the same logic with the memset function we just did. You know, the memset function takes in three characters, three parameters. This one also takes in three parameters: the destination uh, string, the source string, and the number of bytes that are to be copied. The number of bytes to be copied. So we can just do something very, very easy and then we'll continue. Are there people in this call? Let me check.
Yeah, we're here.
Yes, we're here.
Oh, you guys are up to it.
Yeah.
No, no. There are just five. You are the remaining three.
Okay, yeah.
There are three of you.
All right, so let's continue. Maybe I should leave with my phone. Better. So let's do this. But I hope we are understanding what I'm doing. Because I'm taking very gradually, I'm taking very slow so that we don't miss, so I don't be as though I'm rapping. You know, when some people will be teaching or be rapping and your brain will just be like, what is this guy saying? Please, I hope we are following very line by line, precept by precept what I'm doing. I hope we are making sense of what I've been doing.
Yeah.
yeah. To a point, yeah.
To a point. Where is the point?
I from when I came online, I understood what you said about the two-dimensional arrays.
Okay.
Yeah, but I don't know what I missed when I was not online. So that's why I said to the point.
You missed out to insert an element into an array that has already been declared.
Okay.
Actually, then also I wanted to show you guys how to delete an element that have been declared, but it's not really advisable. So I don't want to take that risk. It's not advisable to delete an element that has been declared. It's much more better that you insert into it or you overwrite it or something like that. So let's continue. Now I want to create our source. Create my source. Let me say S source. Right. Set it to 50 for example. Set it to 50. So let me say this is a string that has HTTPS and www.github.com slash poly slash pointers dot git. Okay, let me say in this place, this is a website, a web address, and I want to copy it into another string now. Scar, this is the destination string. Also set it to 50. Right, so there's nothing really there. This is empty. So I want to, oh, I'm not copied. Anyway, let's just go. Let us go. I wanted to copy something into this destination string, but then I remember we have not treated the copy, but it's still the same thing. Just copy. Look at it, very simple. When you want to copy one string to another string, use this strcpy function.
We did it before now.
Yeah, we did it, but
Yeah.
thank God. So I want to copy something to it. Let me say destination is a string, and then what I want to copy into destination string is hello Namibia, for example. Right? I can say, okay, before I used the mem copy function, this is what was in destination string. Right? So then I want to copy something else inside. Full memory space, that's what I want to copy inside destination string. So I'll come here and say destination, which is my first parameter, source, my second parameter, right? Now the string length of what? Of source. Was 1 because of that number of bytes I want to do, the third parameter I told you about. You can browse it up though. Say this is the number of bytes to be copied. So after that you can say printf after mem copy dest mounted. Okay, dest became right. Dest became same thing, destination again. So if you see, we didn't change anything. So you can see that if we, by the time we print that, you see the changes. So it's still the same dest. Return 0. So you can see now. Now the first thing we copied into string was Hello Namibia. So dest contained Hello Namibia. But later on, we use the mem copy function to copy from the source to the destination and including the bytes in that particular space. That is the full memory. Now that's what the memory area, that's what we copied. So it's more like it's a first copy. Are you together, guys? Are we together?
Yes, yes.
So
Yeah,
it's
yeah.
more so it's more like it's a first copy. That's what we did now.
Mm,
Copied it now from the source string to a destination string. So this now we expect this to contain the website, this website, GitHub repository. So gcc mem cpy.c, right? Oh, 7, 8, 11. Seven. What happened? Seven, 8, 11. 7, 8. See that
I think the error on the number 7 was because you did not close the number 6 with the semicolon.
okay, yeah. Gaskiya.
Ayola, your eyes sharp gone.
Gaskiya. Me, I'll just be typing and going and okay, let's just
Guy,
and so now that's the power of youth now. Still very young, unlike us. So what okay, I'm supposed to use this. I'm supposed to use a comma here.
For this, okay.
Sorry. So before the mem copy, what was inside this was Hello Namibia. But after we did that, after mem copy, this became what? https www.github.com/empoli pointers.git. This is an actual repo. So you could copy and what? Copy and git clone it.
So LS will now flag us that
Yeah, let's not flag you in.
you are a contributor to our GitHub.
No, yeah, let's not flag you. You could just whatever it is that you want to do. So, anyways, so I think with what that we have done today, let us
Before
see.
we go, please help us open the code one more time again.
Okay, this particular code.
Yeah, yeah.
So we're going to look at. Let me stop.